joining us for today's webinar. My name is Pedro and I will be hosting today's session. Today we are presenting Securing Your OTT Clients to Protect Premium Video Content by Pedro Fortuna, Jscrambler's CTO, and Neil Sharpe, Friend MTS's Product Marketing Director. Before we get started, and if you have any questions during the presentation, please type them into the question box in your control panel. We will answer them in the end, and if time runs out, we will answer the remaining questions via email. You will also receive a recording of this session in your email. And about our speakers for today. Our speakers are Pedro Fortuna and Neil Sharpe. Pedro is Jscrambler's CTO, and beyond that, he's a seasoned application security specialist, multiple time speaker, and author of several patents in application security. Neil is Friend MTS's Product Marketing Director, and his broad experience across the broadcast and digital media industry spans live production and video delivery. Today, they'll be talking about OTT clients and how they can be secured in order to protect premium video content. Neil, the stage is yours.
Thank you, Pedro. Okay, let's go straight into a quick overview of Friend MTS, just in case anyone's unfamiliar with the company. Friend MTS delivers managed services to stop streaming piracy, which is one of the biggest threats to paid television. We're focused on protecting premium content and revenues. We're not selling software or hardware. We offer a service that's geared to stopping streaming piracy. This is done with global channel monitoring, which uses fingerprint-based content recognition to identify streaming piracy. This monitoring connects with our subscriber-level watermarking to identify the individuals behind the streaming piracy so the service can be deactivated. Our subscriber-level watermarking, called ACID, it's the most widely used in the world. It's deployed by many of the largest media and entertainment companies. In recognition of its work in content protection, Friend MTS was honored with an Emmy Award just a few weeks ago at NAB. Okay, that was just a quick overview of Friend MTS for anybody less familiar with the company. Now let's get back to the problem of streaming piracy. Perhaps the toughest challenge in terms of to address is premium content protection is live sports content protection. The success of premium live sports has made it a primary target for video pirates. It's an especially tough challenge because live sports typically last for just a couple of hours, and the value of the content diminishes rapidly afterwards. This means there's a need to tackle the streaming piracy in a matter of just a few minutes. The scale of streaming piracy associated with live sports is simply staggering. A major live sports content owner may have to deal with thousands of illegal streams during a weekend. This represents a big problem worldwide, which impacts revenues across the whole content delivery chain, from the rights owner to the pay TV platform. The reality is that commercial DRM and CA systems are just not enough by themselves to deliver end-to-end security for sports and premium content. To explain the security challenge, I'd like to use an analogy about household break-ins. A typical robber will look for the point of weakness and try the front door and then the back door to see where is most vulnerable to entry. We see this as similar to streaming piracy, where the pirates will try to identify a pay TV platform's point of weakness, first by probing the set-top box and then the OTT player. They'll try to capture content from a set-top box via the HDMI output using an HDCP stripper. With OTT delivery, they will often use freely available screen recording and streaming software like OBS. One of the key things we're seeing these days is that streaming piracy is becoming very sophisticated. It has matched the legitimate television world in terms of its evolution, with a multi-screen experience that spans big screen TVs to mobile phones. Streaming piracy can be received in many ways, including by illegal streaming devices, Kodi plugins, mobile apps, social media, and websites. Pirate services sometimes offer an array of channels that's even wider than that provided by legitimate pay TV businesses. It's now possible to find just about every sports channel in the world. And the pirate services are often very professional looking, sometimes branded to look very much like legitimate pay TV channels. So they're much more acceptable looking in people's homes. Another dimension to the streaming piracy threat is that many millennial consumers are very savvy about accessing pirate content. They know where to look for pirate content, and they're often comfortable viewing the media. Unfortunately, the growth in bandwidth to the home is also making pirate content even more accessible. At the moment, the most popular video formats for live sports streaming piracy is 720p. This is because it delivers a good enough quality for big screen TVs. But we're seeing 4K streaming piracy, and this will continue to grow with the expansion of 4K channels. This chart here is showing the bit rates and resolutions for typical live sports streaming piracy, and you can see the hotspot on 720p. It all adds up to an existential threat to pay TV providers unless streaming piracy is taken very seriously and proactively tackled. Fortunately, we're seeing that contents right owners are introducing mandatory protection for their assets. Subscriber level watermarking is becoming essential for premium content delivery. Okay, so how can you defeat streaming piracy? Global channel monitoring and subscriber level watermarking deliver the most effective security for premium sports and entertainment content. It's available now for 4K, HD, and SD assets. Global monitoring and subscriber watermarking can be highly automated to allow scaling for the largest live sports content owners, which often have to deal with thousands of pirate streams over a weekend. And it works across all pay TV platforms, including OTT and traditional platforms like satellite, cable, and IPTV. This includes OTT players and set-top boxes for delivering live and on-demand content. Due to the scale of the streaming piracy problem, the optimum approach to global channel monitoring is to use video fingerprint-based content recognition to automatically identify streaming piracy. This is due to the sheer scale of the challenge that needs a high level of automation. A 100% content match can be made in just a matter of seconds. Monitoring involves crawling across hundreds of thousands of websites, Kodi plugins, pirate IPTV operators, and standalone IPTV addresses that have been identified as hosting pirate content. Naturally, the database of target sites must be expanded continuously. The fingerprinting used for monitoring must be ultra robust to normal video processing, as well as tampering by pirates who may try cropping and masking of content. Once the monitoring identifies streaming piracy, automatic watermark extraction is used to determine the individual subscribers responsible for the illegal redistribution. By connecting directly with pay TV operators' subscriber management systems, pirate streams can be deactivated within just a few minutes. This makes this type of service ideal for the most demanding applications like live sports. Our OTT subscriber watermarking uses an ACID client SDK, which is deployed in the client player. This SDK controls the sending of a watermark to the client player by the cloud-based ACID OTT service. This cloud-based workflow is seamless to the consumer, as well as ultra-secure. Importantly, this invisible watermarking maximizes security while also delivering an outstanding consumer experience, which meets the requirements of both sports rights owners and movie studios. To provide a recap of the workflow, here's a quick overview of the global monitoring and subscriber watermarking process. Premium content with fingerprinting is delivered by OTT and set-top boxes. It's watermarked by the client devices, the set-top box and the OTT player. The First step in the anti-piracy process is global channel monitoring, using fingerprint-based content recognition to identify the streaming piracy. And the next step is extracting subscriber watermarks to identify the individuals responsible for illegal redistribution. And the final step is subscriber termination via direct connection with the pay TV platform subscriber management. Okay, so let's look at securing JavaScript clients for OTT. The key issue here is that OTT players can be vulnerable to attack by pirates. Pirates can potentially access the OTT player JavaScript content. This can result in a circumventing or blocking of the watermarking protection. The good news is that by using Jscrambler's JavaScript scrambling, OTT players can be hardened effectively against pirate attacks. The OTT player must be securely protected with Jscrambler to prevent exposure of the ACID watermarking client code to external parties. The OTT player and the ACID code are obfuscated together to ensure that any attempt to circumvent ACID watermarking will also disrupt the operation of the player itself. Friend MTS has found that Jscrambler's tools have been very effective. They deliver easy to deploy obfuscation for ACID watermarking, and there's a close working relationship between the companies. Companies have worked together on key projects like at beIN Sports, and there's ongoing collaboration for other projects. I'll now pass over to Pedro Fortuna at Jscrambler for a deeper dive into the JavaScript protection. Pedro, are you able to take over?
Sorry about that. We had some technical issues with my microphone. I guess that you can hear me now.
Yep, go ahead.
So thank you, Neil. Like you said, Jscrambler can be used to protect the client-side integrity of your OTT player. But what do we mean by ensuring the integrity of the OTT player? We'd say that you have client-side integrity when your player is executed the way it was developed. Its services and contents are only accessed by authorized users, and it's used in strict compliance with its software licenses. Integrity can be ensured by using or combining different protection mechanisms, like for instance, Friend MTS watermarking and Jscrambler code integrity. With Jscrambler, you can protect your OTT player or application by concealing applications' inner workings, like any algorithm or technique you want to keep hidden, by protecting watermarking solutions or other types of add-ons that are useful for your business, like analytics, DRM, advertising, and that you want to make sure that are working properly. By enforcing licensing agreements, by making sure that the application will be executed in the expected environment and by authorized users. and by safeguarding the user's experience, making sure that your UI and the way that you communicate with your users is not tampered with. And finally, by preventing competitors or hackers from stealing your IP, for instance, to reuse it without permission. To protect the code of the application, we rewrite its code in build time. So you deploy already protected source code, and for that we use a number of different techniques when transforming the code. First one is obfuscation. Currently, we are the only solution that offers the most advanced JavaScript obfuscation techniques that, combined with polymorphic behavior, transforms your JavaScript code into a form that is protected against reverse engineering using automated static analysis attacks. But obfuscation should not be mistaken with minification or uglifiers, which is only meant to optimize the code and does nothing to protect it. And it can usually be reversed with simple tools that you can find online. Here you can see an example. On the left side, you can see the original source code with everything very neatly indented. Source code comments, readable strings, meaningful names as variables and function names, and a clear structure and control flow that is easy to follow. On the center, you can see an obfuscated version of that, which is very difficult to read. So for your convenience, we present at the right a beautified version of the same obfuscated code. Here you can see that all the names and strings no longer make sense, and the control flow is completely different. Very hard to understand what's going on. And by using polymorphism, we can deploy new versions of the same code that have a completely different form, which creates a moving target for attackers. But this is just obfuscation. We go way beyond that. For instance, we also install code traps. So code traps is extra code not present in the original source code that enforces something about the way that the application is executed. We can control where, in which domains the application is executed. We can control when or between which dates the application should execute. And we can control in which platforms, like browsers or OSs, should the application execute. If we detect something is off, we can react, like breaking the application on purpose. Also, these traps are very resilient. They are instrumented throughout the code, leveraging obfuscation, and are applied to different shapes and forms so that it's hard to remove them all. In the third layer of defense, we can also make your application self-defensive. Your application becomes able to detect tampering, debugging, or poisoning activities. If any of these activities are detected, the application is able to react by, for instance, derailing the code execution to prevent the attack from being successful and frustrating the attackers. And this protection is completely self-contained in the code. It does not have any external dependency. It does not check with an outside server or anything. If any attack is detected, the application can also launch countermeasures. You can, for instance, set up your app to warn you if your code is being tampered or used in a different domain or environment other than the one that you have defined. But you can do plenty of other things, like executing a custom callback, delete cookies, which is a great way to kick the user out of the web session, redirect the user to another website, or simply by breaking the application. We work with each client to find the best settings for protecting their specific source code and to make sure that we are covering all the security concerns of the users. We have done that work, and we have been doing that work with Friend MTS and their watermarking solution. Deploying Jscrambler is very easy. You just need to call Jscrambler from your existing build process, and it returns back transformed code. That code then follows the rest of your normal deploying workflow, for instance, passing through QA and deployment processes. You don't need to change how you code your application. In fact, your developers don't necessarily need to know that Jscrambler is even being used. Transforming the code always has the potential to impose a performance impact and file size increase. First, there isn't really an average impact, like a figure that I can quote here. It really depends on the specific application source code that we are protecting. But what is more important to understand is that this impact is easy to manage. With Jscrambler, you can use code annotations to enable, disable, or customize transformations to the smallest level of granularity, if you want, down to a line or to a function. So this allows you to optimize performance, tweaking parts where performance is most critical, and at the same time, you can also increase resilience in parts where security is more sensitive. And if you run into problems, we have a team of application security experts that can jump right in and help you. You can share with us what your specific protection concerns are, and together we can make sure that you are using the best possible protection settings. And this is, again, what we have done with Friend MTS. So concluding, there are simply too many ways one can mess with the web player's code and content. And you need to use client-side protection mechanisms to make sure that the delivery of your assets are done in an efficient and secure way. So that means using a watermarking solution that does not compromise the scalability and performance of your web player, and also means protecting all your JavaScript that is running on your user's computer, be it your web player, your ads, your security solution, or all the other parts of your online presence. This is all we have for today. I look forward for your questions.